So today I will explain to you polynomial function. We have limit here. Our limit here is 2 and our f of x is a binomial function. We have here negative 2x squared plus 3x minus 6. After distributing the limit, we have here negative 2 times 2 squared plus 3 times 2 minus 6. So after that, we're going to combine like term. So we cancel out this and we have here, our final answer is negative 8. Now I'm going to explain to you rational function. Our f of x here is x squared minus 4x plus 12 all over x minus 6. The first thing we're going to do is factor out. Since we can't do direct substitution here, because if we apply the limit, it's going to be 0, which cannot be. So if we're going to factor the 12, which is 12 minus 6 times 2. Now we have negative 6, because it's negative 4. Negative 6, x negative 6, x plus 2, all over x minus 6. Since we have similar term here, we're going to cancel that out. So now we're going to substitute our x plus 2, giving us 6 plus 2, which equals to 8, and that's our final answer. And now I'm going to explain to you how to do conjugation. Our f of x here is 2 minus 2x squared minus 2 all over x minus 1. To do this, we're just going to times the radical by itself, which leaves us to this equation over here. And now, since we have 2 squared here, we can cancel out the radical. And 2 squared is equals to negative 4, since our sign here is negative. Now we're going to combine like term, like positive 2 minus 2 negative 4, which leaves us to this equation, 2x minus 2. And we can simplify them, which is 2 close parenthesis x minus 1. Now we can cancel out the x minus 1 and leave us to this equation, which is 2 all over 2 plus 2x squared plus 2. And now we can apply the limit, which is 1. And now we can simplify this equation, which results to 1/2.
Good day, everyone. Today, I'll be fun discussing lesson 2, length and right limits. Here you can see 2 examples, and today I'll be showing you how to solve them both. So here is the first example. So what you need to do first is to find the biggest exponent. So after picking the biggest exponent, all you need to do next is direct substitution. So in order to multiply this, you have to multiply itself 3 times. It is still negative. But since there is a negative here, you have to multiply it. So split it times negative maybe equals positive 18. So therefore, it is positive. And here you see another example. Like I said, pick the biggest exponent. So was still direct substitution, negative. Since our limit is negative 3 and add to 4, and still you need to multiply the negative and negative 4 times. This negative turns into positive. But since we still have an exponent here that is negative, so we multiply that with positive. So times positive 18 equals negative 18. Therefore, Yes. So here is our last example, which is right left table. Here is our example. F of x equals 5x plus 2. Our limit is 1. Keep in mind that right is always rapidly decreasing to the limit, while left is rapidly increasing to the limit. And since our limit here is 1, our numbers here is decreasing to 1. And here is increasing to 1. You can pick any number as long as it is approaching to the limit. So, as here, after you get the numbers, all you need to do is direct substitute them to the given problem. So here, first, you direct substitute this number. So 5, open parenthesis, 1.02, close parenthesis, plus 2, which gives us 7.1. After you, just like here, you also direct substitute it, which gives you these answers. So that's how you get the f of x. Just like here, you also need one. All you have to do is direct substitute them in order to get the answers here. And surely after answering them, you can see a pattern. And in this case, it is chain to 7. If you really want to verify if the limit is 1, 7, or any number, you can just direct substitute the problem with the limit. So 5 times 1, since our limit is 1, plus 2. 5 times 1 is still 5 plus 2. So it makes it 7. So therefore, the limit is it. Okay, one of them we will talk about the limits of transcendental function. First, I'm going to talk about exponential function. Our limit is 3 to the right. To get our x, we need to find a number that is equal to 3. So we got 2.05, 2.98, 2.99, 2.999. To get our x, we need to direct substitute it into our f of x to get our f of x here. So we just input this in our equation to get this. So we just integrate all of our x. And second one is limit 3 to the left. So to get our x here, we need to find a number that is equal to 3. So we have 3.05, 3.01, 3.001. To get our f of x, we direct substitute this to our f of x here. Direct substitution din f of x, din add to our f of x. then we get 38.593, and we must use and give it this. And the second one is logarithmic function. And this is just the same as exponential function, but the difference is we have formula which is log to x, and our limit here and x is 5 to the right. To get our x here, we need to find a number that increasing to 5. So we have 4.8 and 4.9, 4.98, and 4.9399. To get our f of x here, we need to use our formula, which is log 2x, that we get this 2.263 and 2, and we in this. And the second one is our limit is 5 to the left. And to get our x here, we need to find a number that is decreasing to 5. So, which is 5.5, 5.1, 5.01, 5.001, and 5.0001. We need to use our formula again, which is log 2x, so that we get 2.459, 2.350, 2.324, and 2.322, and 2.321.
So trigonometric functions. Let's evaluate cot or x with the limit of pi over 6. To solve this, we need to solve our x first, which is pi over 6. To solve that, we can times it with 180 over pi. So we can cancel the pi and turn it into 180 over 6 to 30 degrees. And then that's where we can add our cot. Well, we can, if your calculator can, you can direct substitute it with cot and 30 degrees. But if your calculator can, we can times 4 by 30 degrees, which gives us negative 3 over 3.
We're going to be talking about lesson 4 about discontinuous and continuous. So starting off with discontinuous. Discontinuous has holes and jumps an infinite number. This is the example of discontinuous. F of x equals 1 over x to the power of 2, and x equals 0, x equals not 0 is an example of discontinuous because 0 is not a real number. So continuous function, lines that no graphs, jumps, parabola, or holes, or a part of a domain. This is the graph. F of x equals x plus 1 is continuous function because it has a line, and that means it has no gaps. Here is another example of discontinuous. F of x equals 1 over x minus 1. F of x equals x to the power of 2 minus 1 over x minus 1. F of x equals open parenthesis x plus 1 close parenthesis open parenthesis x minus 1 close parenthesis over x of 1, and it's not continuous because if you look at the this, it could still be solved as 0, and 0 has no.
Everyone, today I will be explaining to you lesson 5, verifying trigonometric identities. So first, in our first example, which is CSC, x tan x equals sec. To verify this, we can change CSC to 1 over sin x. I will be showing you a
a guide how to solve this. But as we all know, CSC is the reciprocal to 1 over sin x. We can also change tan x to sin x over cos x. This can get us to cancel sin x and the other sin x's. They are both the same. We can also change CSC or sec to 1 over cos x, which gives us cos x equals to cos x. Our second identity, or our second example is sin x and tan x plus cos x equals CSC. So let sin x just be sin x. And we, of course, we all know that tan x is sin x over cos x plus cos x. We can now simplify this by adding or multiplying sin x and sin x. So sin x is just sin x over 1. So we can now, this can be turned into sin x squared over cos x. So, and plus cos x squared x over cos x. Why did we get cos x squared over cos x? To do this, we can just times cos x with itself. So we can have the same denominator, giving us sin squared x plus cos x squared over cos x. Since we all know that sin squared x plus cos squared x is equals to 1, we can change that to 1 over cos, or cos x, which gives us the same as our CSE or sec or 1 over cos